Hey guys, welcome back to the next video. Now in this video, we are going to run some tests to see how, how your horizontal pod autoscaler is working. Now do remember that to simulate this, we may have to create or run multiple load balancing. So I've logged into manager server in 3 different consoles. So you have manager one, manager one, manager one. So all these are in the manager server. So now I'm going to run this command. Now this command is a very simple container. So this is a kube control run -i -tty is basically I've given the name of this pod which is going to be created. So it's a command line method of creating a pod. And here it's going to use a busybox image, very simple image. Okay, it's a very fast image as well. And then restart as never, and then -rm will remove this particular pod if I do a control C. Okay, so now if it quits, then it removes. Now what it's going to run is like it's going to run a shell -c with this while loop command. So what it's going to run is like it's going to run my service name over here, Tomcat Apache. That's the service name, Tomcat Apache. So it's going to run with 80 samples. Okay, so once it is running, then it's going to like create some load on the server. So let's see. It's going to create this particular load generator as a pod, which you will see that over here. So now you can see that the load generator is running right now. I can see that it would obviously create a load, but it takes few seconds for it to reflect the load over here. You can see that the application is loading. Now what I'm going to do is I'm going to run this on another system as well. I cannot run it with the same name as the pod because the pod has the name. So I'm just going to change this to like load generator 1 as the pod name, and I'm going to run this. I can see that the load is increasing, and you can see another load generator is running simultaneously. I'll be running another load generator over here as well. So that generates more load. Now, as a result of running all these things, now you can see that connection refuse is coming because you see the pod, the replicas are getting increased because the load is getting increased on the on this particular instance. And you can see that the replica has changed to 3. Autoscaler is creating 3 instances of your Apache pods over here. So it's scaling up right now because the load on the system is huge. It's about like 49%. Now I'm going to run it one more time over here with the load generator 2. And you can see that the load keeps on going up to 92%. So to avoid that, to compensate this, it has created 6 replicas right now. Now it has created 10 replicas right now because the load is too much on the server. You can see that all maximum is being utilized right now. So you can see how you have like 10, which is the replica set. So this should also go to 10 over here. Like you see that it's gone. So you have worker 1, worker 2 serving request, and you can see that you have 10 pods running. So this is what happens in terms of a high load utilization. But then what happens if I do a control C everywhere? So now the load will dramatically fall down, and you can see that it's already reflecting over here where actually before you even do the control C, the load was coming down because of the number of servers there picking up the request. So the more servers serves the request, as it is part of the cluster, the load gradually came down. Now that I have canceled all my requests, right? So there is no more requests. Now the load will go to 1% or 2% eventually. And when that happens, I want this autoscaler to scale down because I don't want to use my resources, because the more the resources I'm going to use, the more the charges I'm going to get, the more the power I'm going to use. So in which way I want it to scale down as well as it scaled up. So let's see if that happens in this situation. Now you can see that these services are created like 92 seconds before, and some are 109 seconds, some are 12 minutes before. The 12-minute one must be the first one which was running for a long time from the last video when we did this configuration. So what I want to see right now is servers getting terminated. So I'm going to give it like 3 to 5 minutes for it to relax and reflect on this, because there is a timeout setting which happens on the back end, which will relax your going back to releasing these servers, saying that, okay, for sure, I'm not going to get any load because for the last 60, I think the timeout is about 2 to 5 minutes, I guess. And that's the time it's going to wait to confirm that there is no increase in the load. And then it's going to remove the service which is not, working as part of handling the load. And it's going to come to the minimum pod. So let's look at that. I'm going to pause this video and post this once that is done because I don't want to waste your time. All right, so now you can see that it has gone down to 7. It's just like 5 minutes almost. So every 5 minutes, it's just gonna realize those servers and it's going to terminate. Like you see that two servers are getting reduced. So it's 7 and then now 5. And then it's gonna eventually come down to 1 because it just monitors for 5 minutes and see if there is any kind of a load which is still remaining. So you can see that that's all gone. So now you are back to minimum pod, which is 1. And this is how it basically scales down. And if you have any questions, do leave it on the questions section. So this is pretty easy to achieve, but then it has a lot of configuration and you need to be very careful in terms of configuring all these action items. I've explained you step by step, so you won't be failing in any of these steps. Thank you again for your patience and time. I will see you on the next video.